In our Unit 13 review, we'll look at features of parabolas, including things like x and y intercepts, axis of symmetry, vertex, a values. We'll look at graphs of parabolas, both graphing them on the calculator and matching graphs to equations. And we'll look at quadratic word problems, where we look at maximum height or profit using the vertex, and time when things hit the ground using the roots of a quadratic. Number 1, using the graph, determine the coordinates of the zeros of the parabola. So zeros means the same thing as x-intercept or roots, or less common but still possible solutions. And that represents these dots right here. So that is the coordinate for 0 or the coordinate to 0. You might see it listed as the roots being 2 and 4, or that the zeros are 2, 0 and 4, 0. X-intercepts are the same thing. That's where it crosses the x-axis. This is at -5, 0 and at -1, 0. Next up, the y-intercept. That's this point here, 0, 6. That's where the graph crosses the y-axis. The coordinates of the vertex. It's either going to be the top or the bottom point. So if my parabola looked like this, then it would be here, and it would be the minimum. Or here, this is the maximum. Those are the two possibilities. The coordinates here are -3, 4. Next up, axis of symmetry. So this is a vertical line that passes through the middle of the parabola. X equals 1 is the axis of symmetry. A couple things are true about a values. When they're negative, they open down. So that's going to be this one right here. And when they are a bigger number, this means they are narrower. So the 4 is going to go over here. And then this one's just going to be a 1. The reason why it's a narrower graph is they grow faster, because they're being multiplied by 4. Coordinates of the vertex using the algebraic formula. So we're going to use -b divided by 2a. And here we recognize that a is 2, b is 28, and c is 92. So if we plug in these values, we have -28 divided by 2 times 2, which is just -7. We're going to take that and we're going to plug it in. So 2 times -7 squared plus 28 times -7 plus 92, and that equals -6. So this is my x coordinate, this is my y coordinate, my vertex is -7, -6. It's a little bit easier when they just want to know the equation of the axis of symmetry. I still use -b divided by 2a. A here is 3, b is 42. So it would be -42 divided by 2 times 3, which is -7. So the answer is just x equals -7. To find the x-intercepts, what can I plug in to make this 0? Notice if I plug in a 4, that'll be 4 plus 4, which is 8. That's not what I want. So the answer here is -4 and -5, which matches with these right here, and our answer is D. Another way to solve this would be to set each factor equal to 0 and solve them separately. You would get the same answer, like this. For the y-intercept, it's different than the x-intercept. You're going to plug in 0 for x. So this becomes 0 plus 2 times 0 minus 1, which is just 2 times -1, which is just -2. And we want to find where that exists for the y value, because it's our y-intercept. Number 11, to graph this, we're going to y equals, in our calculator, we're going to put this equation in there. Then we're going to press second graph, which pulls up the table. And the table that we find looks like this. So looking at our y values, you should notice that this is our vertex because there is symmetry around it. So we are looking in the y column to find that. And when we plot our points, we have to include the vertex as well as the roots. The roots are going to be the ones that have 0 for y, like that. So here's our first point, -5, -3. Then I have -4, 0, -3, 1, -2, 0, and -1, -3. And I'm going to sketch the curve of my parabola like this, and I'm done. For this one, again, I'm going to put the equation into y equals. I have x squared plus 8x plus 12. I'm going to press second graph to pull up the table. If this is what my table looks like, I want to look for this symmetry right here. That means that the middle value is my vertex. So that's -4, -4. I have to include that. Vertex is done. Now I need to graph the roots. That's a root, and that's a root. So I have to include those, -6, 0, and -2, 0. And then I can plot any 2 points. Let's just go ahead and do -5, -3, and -3, -3. I'll sketch a parabola that goes through these points, and I have graphed my equation. So this is written in factored form. What I'm really paying attention to are that my A is positive because it's opening up, and that my zeros are 1 and 2. So these are numbers that I plug in. So that means that my factors are x minus 1 and x minus 2. So if I look at my answer choices, which one has a positive a value? Not this one, not this one. And which one has these factors? That answer would be B. Next up, I see that my a value is negative because I'm opening down. My zeros are 2 and 4. So if I wrote those as factors, it would be x minus 2 and x minus 4. So I'm looking for a negative a value and factors that match these. Letter C. This one is written in standard form. So my a value is going to be negative because it opens down. And my y-intercept is equal to 5. So I'm looking for not these, but one that has a negative a value, and then my y-intercept has to show up in the equation. Choice C. This is another standard form question. I know that a here is going to be positive, and my y-intercept, again, is 5. So it's not these two because those have negative a values, and it's going to be B because it matches the y-intercept. This one is in vertex form. So I pay attention to that my a value is going to be negative, and my vertex is 1, 3. If I was to turn that into an equation, so my vertex is 1, 3, it would work like this, x minus 1 squared plus 3. Notice that the x is opposite, y is not. So I'm looking for a negative a value. They all have that. Doesn't rule out anything. And I'm looking for one that says x minus 1 squared plus 3. So the answer is C. This one again is in vertex form, so I'm looking specifically here. My vertex is -3, -6. How do I turn that into an equation? Notice that the x is opposite and the y is not. So which one matches? And also that my a value should be positive because it opens up. So I'm going to rule out these two, and the one that matches is choice A. So we're going to put equation in y equals first. We're going to graph. After that, we're going to press zoom 0 if it doesn't fit. That changes the window of our graph so that it does. So at this point on your calculator, it's going to look something like this. This is your calculator screen. You have your grid like this, and you have your curve. And what we're doing is launching a rocket. And the highest height of the rocket is going to be here at the vertex, which is also known as the maximum. So what we can press is we can press second calc and choose maximum. And it wants you to choose a left and right bound from that maximum. All that means is you're going to move your blinking cursor until it is left and lock that one in right there. Then you're going to move your blinking cursor until it is right of where you know your vertex is. Press enter twice and it will give you answers like this, that your maximum has an x value of 5.96 and a y value of 667 point something, and it wants you to round to the nearest tenth. So we're going to take a look here, and looking to the right, it's a 1, so the answer will be 667. And the steps for this one are actually the same for number 20. We're still launching a rocket, but they want to know the time when it will reach its max. So we're still looking at the vertex, but we're looking at the x-coordinate of the vertex. The directions are the same. First we put the equation y equals, we press zoom 0, and then we're going to press second trace, which is the calculate menu, and we're going to choose maximum. Then we're going to go left of the vertex, press enter, right of the vertex, press enter, and what you will get is your calculator will show this screen. And it'll say maximum x is equal to 5.4374 and y is equal to 584.06. And the answer for this one is about the time, and it wants it to the nearest hundredth of a second. So I'm going to look here at the 3, and I look to the right and it's a 7, so I round that up to 5.44. I guess I could put the unit for this one. This was feet. This next one, it wants to know when it will hit the ground. So it's not looking at the vertex anymore, but we're still going to put this into y equals. We're going to press zoom 0 to make it fit, and then we're going to press second trace to pull up the calculate menu. And instead of pressing maximum, we're going to choose the 0. And if this is what our calculator looks like, we want to find this right here. This is our goal. So when we choose the left bound, we're going to choose a blinking cursor that is to the left of that 0, like maybe here. Then we're going to choose a right bound that is to the right of that 0, so maybe down here somewhere. We're going to press enter twice. And we get as an answer that our 0 is x equal 13.9829 and our y is equal to 0. So they want that to the nearest hundredth of a second, so we get 13.98 seconds. If it doesn't work, you have to press window and change x max to a bigger number. And what that does is it extends this window so that we look at more of the graph so that you have a chance to see that 0. But most of the time it'll work as is, but that would be the fix if it doesn't. All right, the last two, no longer talking about rockets and towers. Now we're looking at prices and profits. But guess what? It's still a curve. So this is our graph and our situation. We are looking at this curve and we want to find the vertex. And that'll be when we have the maximum amount of profit, because profit is our y and price is our x. So here for 22, we're going to calculate the y value of the vertex. And then for the next one, 23, we're going to calculate the x value of the vertex. So we do the same things where we put it in 2. Y equals, we press zoom 0 to make it fit, and then we press second trace maximum. And then we're going to try to find the maximum on that graph. For left bound, you want to choose something like this. For right bound, you want to choose something like this. You'll see if you actually press these buttons what that means. And the maximum y value is 1,301.25. They want it to the nearest dollar. So we're going to round that to 1301. Next up, we follow these same steps. We put it into y equals. We press zoom 0. And that says y equals. We press zoom 0. And then we press second trace maximum. So this is our curve. We want our left bound to be here, our right bound to be here. This will be our vertex. And when we find it, that maximum will be x is equal to 40.5 and 00011. They want it to the nearest cent. So I think we can say $40.50.